Welcome to this workshop on PID tuning. In this workshop you'll have an opportunity to tune a control loop based upon identification of the process response to a step input. Also, in this exercise we will examine the response of the control loop to both set point and disturbance changes, and to see the impact of tuning on the response that is provided for each of those. Based upon this exercise, then we will address the question of what trade-off is often made in tuning for disturbances in set point. The process that we'll use in this workshop is the heater, in which a liquid is heated, temperature is measured, outlet temperature, and the PID is adjusting the steam flow. The disturbance input is the temperature to the heater. So let's get started in our workshop. To identify our process with the control being in manual, we can change the output by a step. So in this case we'll change our output by about 10%. And as we notice, as we change the output of our control, the process input immediately changes, and that has an impact on the process output. To see the process response, we can look at our chart, and from this we identify that the dead time is about 3 seconds, and the time constant, that is the time to get to 63% of the change from initially changing, is about 7 seconds. So the dead time plus time constant is about 10 seconds, so we know our reset of our PID control needs to be set to 10 seconds. Going back to our PID, we notice that the reset of the PID is already set to 10. If it was something different than that, then at this point we would change it to 10. Looking at our control options, we see that the controller is set up for reverse acting, that is, direct acting is not selected, which is correct in this case. To tune our controller, we are going to start out by putting in a very low initial gain. So in this case we'll put in a gain of 0.1, and then we're going to then verify the control response by putting the control into auto and then changing the set point. So we'll change it to auto. We expect no bumps since the set point is tracking PV in this case. When we change the set point, then we should then see how the PID responds with this tuning of a reset of 10 and a gain of 0.1. As we can see, in response to our set point change, the output is changing and the process output is also changing, our control parameter of our PID. To better examine this, let's look at our chart. When we go to our chart, we see that in response to the set point change, that the process is very gradually changing towards set point. So in this case we can surmise that the gain is much too low. So going back to our PID, we'll increase our gain to 0.5. And after changing our gain, then we'll go back to our chart and just see the impact of that on the rate of change of the control parameter approaching set point. And we notice that in response to that, there is a significant change or increase in the rate at which the control parameter is being brought into set point. However, to better assess the impact of that gain change, we need to really change our set point. So we'll go back to our PID and change the set point. And in response to the set point change, we see the output changes much more rapidly, and our control parameter is also changing much faster towards the set point. This can be better visualized by looking at our chart. We can see where we changed our set point with a gain at 0.5. It's much more responsive than it was before to the set point change. However, it's still a little sluggish for this loop, so we can go back In this case, we're going to change the gain to 1. In making gain changes, you want to do those very gradually and test after each change. In this case, where we've changed it to 1, we're going to change our set point again and observe then the response with this higher gain. When we change the set point, we do notice quite rapid change in the control output. We can see the impact of this by looking at our chart. As we can see, we're coming much faster into set point, but we're still not overshooting, so we're still providing good, solid control. And we are brought into set point very quickly. So at this point, we might say that the tuning is good for this particular application for set point changes. Now, to examine the response to disturbances, we can go back to our process disturbance and make a step change in that. So in this case, we're going to make a step change. As we can see, after making that step change, it has an impact on the process output and is reflected in our control parameter. To better see the impact of this, we can examine it in our chart, and as we see, the disturbance drove the control parameter away from set point. With the tuning of a gain of 1, we see that we have a good response to the low disturbance input. To see if changing the gain would improve the overall response, we'll change the gain to 1.5 and then introduce disturbance again to see if higher gain has improved our overall control. So with a gain of 1.5, then we can see that it responds much quicker to the disturbance. In our chart, we see this more clearly. We see that we're coming back to target much faster than we did with the lower gain. To see what this gain change has and how it impacts our set point response, we'll change our set point. In this case, we'll change it by the same magnitude as the previous set point changes, and we'll observe the impact of that on the process response. So we can see this much better by looking at our chart. In examining our chart, we see that the set point response is very aggressive and is almost oscillatory in terms of the control parameter being brought up to set point. We overshoot just a little bit and we tend to deviate and then are brought back into set point. At this point, the tuning is probably more aggressive than we'd like in many cases, but it is the tuning that seemed to give best response for for disturbances. So from this, we can ascertain that there's a trade-off between the tuning for set point change and low disturbance. Oftentimes we have to look at the purpose of the loop and determining how to tune the loop. Is the major purpose of the loop set point response or to respond to low disturbance? We hope this exercise has been helpful to you and that you'll further explore tuning using this exercise.